Okay, first of all, let's take a look at a definition. And hopefully you can all answer this question of what an x-intercept is. We talked about it a lot with linear functions, the x and y intercepts. The x-intercept is also really important when solving quadratic equations. So essentially, an x-intercept is the value of x when you substitute 0 in for y. It's also the point on the graph where the function intersects the x-axis. We have another name for this that we use a lot. It seems like we use this more for quadratic equations, more than x-intercept, but a zero. So zeros and x-intercepts are the same thing. All right, so when solving a quadratic equation, you are essentially finding the zeros or the x-intercepts. Oops. So when you're solving a quadratic equation, one of the forms of a quadratic equation is y equals ax squared plus bx plus c, where we have an x squared term as the highest term. And essentially what you're doing is you are finding where the y equals 0. And I'm going to show you how to do that. So for example, this quadratic equation is already in factored form. And what we're going to do is find the value of x, or values, make the equation equal to 0. So there can be, and oftentimes there are, more than one. So before we do that, one thing you need to know is called the zero product property. The zero product property is simply says if you multiply two numbers together and the solution is 0, the product is 0, then A has to equal 0 or B has to equal 0. So one of those two is equal to 0. And we can apply that in order to solve quadratic equations. So, how to use the zero product property. Well, the first thing you want to do, like I said, when you are solving a quadratic equation, you're finding out where the y values are equal to 0. So we substitute 0 in for y in the equation. So we're going to do that. And then that was the original equation that I had on the last page. And then what we do, we know that either this first factor has to equal 0, or, so this has to equal 0, or this factor has to equal 0. So I'm going to set each factor equal to 0, and then solve for x. Okay, so all that practice you did learning how to solve a regular equation with x is now going to come in handy. So to get x by itself, so we're going to start with x plus 3 equals 0. I'm going to subtract 3 from each side, and I'm going to get x equals negative 3. So that is one solution to the equation. So then here, you're going to subtract 1 from each side. 2x equals negative 1. Divide both sides by 2. And the other is x equals negative 1/2. So we have two solutions for this quadratic equation. All right. So, to show you why this works, or that this does work, I'm going to substitute. Remember, we can check our solutions to an equation by putting those solutions back into the original equation. So if I put negative 3, so I'm going to substitute negative 3 in for my x's. So I'm going to get negative 3 plus 3 here, and 2 times negative 3 here, plus 1. So I just substitute it in, and now I'm going to solve. So what's negative 3 plus 3 is 0, times negative 3, or negative 3 times 2 is negative 6 plus 1 gives you negative 5. So 0 times negative 5 is just 0. So that is true. So let's take a look at the second solution. So we get 0 equals 2.5. Negative 1/2 plus 3 is 2.5, or 5/2. 2 times negative 1, or negative 1/2 is negative 1 plus 1. 2.5 times 0, which is 0. So that checks out. So both of those, so we have two different solutions up here. So x equals negative 3 and x equals negative 1. I'm sorry, negative 1/2. All right, so that example that we just did, this example with a solution of negative 3 and negative 1/2, was already in factored form. So that's the easiest case scenario. If it's not already in factored form, then we want to solve that. So the first thing we want to do is get it into factored form. So remember our strategy, x squared negative 12. And then you have to find what times what gives you negative 12, and also adds together to give you positive 1. So I could do 2 and 6, but that's not going to give me 1. But negative 4 and 3, well, that gives me negative 1. So I know I need to do 4 plus negative 3. And that gives me positive 1. So that doesn't work. So these are going to be our x terms. So I'm going to do 4x and negative 3x. Then once I've done that, I can factor it. So x plus 4 and x minus 3. So our two factors are x minus 4, plus 4, times x minus 3. So then I'm going to set this equal to 0. And then I'm going to set each factor equal to 0. So I would subtract 4 from both sides, so I get x equals negative 4. And then I would add 3 to both sides. So I'm going to get x equals 3. So the solutions, x equals negative 4 or x equals positive 3. And if we put those back in, negative 4 squared minus 4 minus 12. So that'd be negative 16 minus 4 is wait a minute, that'd be positive 16 minus 4 is 12. 12 minus 12 is 0. Or if I put 3 in, 3 squared is 9 plus 3 minus 12 is also equal to 0. I just did a quick check there. Okay, now what I wanted to show you, but I couldn't figure out how to put it into this program, is if you graphed this equation, y equals, so if you graph the equation y equals x squared plus x minus 12, then what you would notice is, let's see, you would, so what you would notice is when you graphed it, you would have the x-intercepts at 3 and negative 4. So if you were to graph this, and I'm just going to sketch this, I don't know exactly, but the graph of this is going to be a parabola, and it's going to be at x equals negative 4 and x equals positive 3. So negative 4, 0, and 3, 0. So if you can, I'm assuming you can since you're watching this video, but you could go to desmos.com and put in this equation. You can even download Desmos free as a free app on your phone. That's pretty handy. And you can graph it, and you'll notice that where it hits the x-axis is negative 4 and 3, and that is the solution to our equation. All right. Okay, so that is all I have for you. I'm taking video requests, so you can email, call, or text, or you can Instagram too. I'm thinking about doing a video on the lesson on quadratics from the first packet, I think it was, or maybe the second. I'm getting all confused. So anyway, if you have any other requests, I can make a short video for you to help you with a particular problem or whatever you need. Okay? So I hope you're doing well, and this is it. This is the last lesson of algebra for this school year. Take care.